Hey, welcome to a brand new day. Yesterday, you learned how to create arguments for your defined functions. You learned that you can have one argument, such as here, or more arguments divided by commas. So at this point, our program is able to get to-dos by calling this function throughout the script, such as here, getting the to-dos in a list through that function. But also, the program is able to write to-dos in the text file, in the to-dos.txt file, using this write to-dos function. So function with one argument, function with two arguments. And another difference between these two functions is that this function here returns something and this function here doesn't return a value. So some functions output something and others simply do some actions when you call them, and that's all. For example, this function here writes the to-dos in a text file and that's all. It doesn't return anything. Today we're going to be looking deeper into functions. You're going to learn about default arguments. So ready? Let's see you in the next video. When you go to order a coffee to the barista, do you say I want a coffee or do you say I want a coffee in a cup? Whatever you would say, in both cases, you would always get a coffee in a cup. So people don't say I want the coffee in a cup because that is the default argument. So it is a default input. The barista always knows that the coffee should be served in a cup. The same goes in here. We always use this to-dos.txt file. So why should we mention it always when we order the function, when we call the function, when we order the coffee? So we do that here and there multiple times. Well, there is a solution for that, and the solution is default arguments or default parameters, whatever terminology you use. I'll explain the terminology as well. So to make this a default parameter, all you have to do, and let's start with the getToDos function, all you have to do is assign the value toDos.txt to the parameter. So now this is a default parameter, and therefore we say that this call has a default argument, so we don't have to provide the actual value of the argument. So in this case, both terminologies are used interchangeably. Default argument, default parameter. So therefore we can remove all these argument values from all the getToDos function, which is 4 of them, like that, and here as well, the 4th one. So if I run the code now and I try, for example, the show method, things will work the same. The benefit here is that if you ever want to change the value of that parameter, you could simply specify the new value. For example, let's say todos1.txt. So I just changed the value in the getToDos call in the add condition. So let me try the code now. Run main, and I'll try to add something so that this line is executed. So add my new to-do, press enter, and we get an error this time. So it says that no such file or directory todos1.txt. The error can be traced in here. So first it occurred in line 19. So errors can be read from top to bottom. So this is where the error started, line 19 in here. So Python tried to call this function, and this function itself tried to call something else, which you see in here. So line 2 is the next one to be executed. So this one here. And that line tried to open the todos1.txt file, which does not exist. That's why we get this error in line 2. 2. So what I'm trying to demonstrate here is that you can change the default arguments. You can just give a value here and that value will replace that value there. So that's the idea with default arguments. So let me go back here and remove that 1 and remove the value itself. We don't need it. And let's implement default parameters with the right to this function here as well. So file path would be todos.txt, but todos arg is not a default parameter because we're always having a different list in each of these conditions. So in this add condition, the user adds a to-do, they provide it in the command line, and then we read the existing to-dos using that getToDos function up here, and then we append the to-do of the user to the list. So now we have a new list here, and we want to provide that new list to the write-to-dos function. So there's no way for the write-to-dos function to have an assumption on what this value could be. So when there is no assumption, you want to keep parameters as non-default parameters. So that is a default parameter, that is a non-default parameter. Now we have this error here. So it says non-default parameter follows default parameter. So this is a problem, and it can be fixed by putting this non-default parameter before the default parameters. So that is the correct syntax. Otherwise, you will get an error. That also means that you should change the positions of these arguments when you call the function, because what's happening now is if I run the script, run main, and I add my new to-do, so we get an error, and it started in line 23 in here. So this is the function call we just wrote, and then it traces back to line 8 where the function definition is. And the error is that this function expected a string, right? Like todos.txt, for example. But in reality, it got a list. And that is because the order of the arguments matter here. So if this is the first value you place, that value will go as the value of the first parameter. So todos arg is actually the string, while file path is going to be the list. So basically what we did is we said file path is equal to the list, which had like multiple to-dos, to do one, and so on. That's what we did. So the open function is confused and it cannot open a file which has as path a list, so it doesn't make sense. Therefore, you should respect the order now. To-dos should go first, and then todos.txt. Or, if you don't like order, what you could do is you could, let me undo this. So if you really want to have the order as you wish, then you could say file path is equal to that, and todos arg is equal to that. So if you explicitly mention the argument names, then you don't have to respect the order. This will work now. So show and add new order, and new order is part of the to-do items. However, I wouldn't recommend this method unless you have to. So just say to-dos first, and then todos.txt. So todos goes to todos arg, todos.txt goes to file path. Actually, since file path is default, as it's a default parameter, you don't even have to pass file path. So you just say todos and that's it. So if I run that, we just made a default arg show, and that's the new to do. So what we did is now we only mention that file path in there because it is not important. We don't have to pollute our code with unnecessary details all the time. Just like the coffee cup example, you don't have to say all the time, I want the coffee in a cup, because that's the default behavior. So let's see what else should we change here. Yeah, write todos, just remove todos.txt and leave only that. Same here. And that's about it. Before I close the video, I want to also emphasize that also built-in functions can have default parameters. For example, if you say help input, you see the help string of the input function, you'll see that the prompt parameter is set by default to a non-object. So that makes it possible for you to just say input without providing a string. So if you say like that, there will not be any string printed out here, no prompt, you just enter this as a user and so on. But if you provide that string will be displayed in here. Some functions though, such as len, so this is a function that returns the length of a list or a string. So for example, hello, it tells you it has 5 items, so 5 characters. So if you do help len, you'll see that this doesn't have a default parameter. So the object is mandatory. That means if you do len without an argument, you're gonna get an error. You see, len takes exactly 1 argument, but you didn't give anything. We would get the same error if we change this get to this function to this. So if you just leave file path as a non-default argument, and then in get to do's you don't mention the value of that file path, and if you execute the code now and you try to add a brand new to do, you get an error in line 19 here. So the function call tried to execute the function definition, but it couldn't, because the function call should have gotten 1 argument file path. So I hope that makes sense, that if you have a default value for the parameter, then you don't have to pass it here. Otherwise, you'll get an error. So that's about this video. Thanks a lot. See you later. Hi, welcome back. In this video, you will learn how to use docstrings. So what are docstrings? Well, you have heard me mention them here and there, but we never explained exactly what they are. So you saw that when we do something like help, and you check the help documentation of a function such as input or print or len, let's try len, you get this documentation. this is actually called the docstring of that function. So if you are on PyCharm, you can actually see where this docstring is written. So in a Python file, just write len, and then right click over it and go to, and then to implementation. That will take you at the file where len is written. Now this is a fake function, but the string is the actual docstring. So this docstring is the one displayed in here as well. So when you do help len, for example, then the help function generates this automatic text help on built-in function len in module built-ins, and it also generates the structure of the function, and then it extracts the docstring from the place where the function is defined. In this case, it is here. So we can do the same for our own functions. So docstrings are written in the first line, and you use triple quotes from both sides of the strings. So then you write the description of the function, so that if your function is later used by someone else or by you, they can use the help function and see the help documentation, the docstring of the function. So what can you write here? Well, we can learn from these functions here. So the len function says that return the number of items in a container. That's what the len function does. So it calculates the number of items in a list or string or other sequence types of objects. And there are other functions as well. So that's the input function. This has more description, and when there is more text, you want to put the text between the triple quotes in separate lines, as you see here. In our case, so make a space and write something. Read a text file and return the list of. So since this is getting too long, I think we can split it and we can write the rest in here. So read the text file and return the list of to-do items. So that should do it. So it's the same format as this one here. So how is this docstring useful now? Well, currently it is not very useful given the structure of our program, but you'll see later on that you can create multiple Python files for one program, and then these files can interact with each other. And then you might want to access the help documentation of a function from another file, and so then it becomes helpful to have this docstring. As an experiment, you could also try the help function in here and say get to-dos, and so you want to print out the output of help. Here in the command line in the Python console, you don't have to use print, as I have mentioned before. For functions, for variables, you just call the variable or the function and you just get the output. But here you want to print the output of help. So let's run the script, and that's what we get. So that's the request to enter a to-do, which is executed by this line. So that's the output of that. But before this, we get this docstring printed out by this help file. So that's the help documentation. As you see, help on function get to do is module main. This is automatically generated by the help function. And then we have a representation of the to-dos function. So it shows what argument it gets. It shows that this has a default value, and then it shows the docstring of the function in here. So read the text file and return the list of to-do items. So now if anybody else uses your function, they can read what the function does by using the help function. And the docstring you write is important. So let me close that, delete that line. So that was one use case of the docstring, when someone else uses your functions or you use your functions through the help file. Another use is, of course, for you directly. So when you write and then read your code, you look at your code later on and you see these functions, you can just look at the docstring, you can read what it does, so that will tell you what this function does, so that you don't have to look at the code. So descriptions are good. Let's write an f string for this function as well. So 3 double quotes, a space, write a to-do items list in the text file. So that should be enough. That's about docstring. So it is recommended to use docstrings for every function. Some people just don't use them, especially when you have very simple functions. But the general recommendation is to use docstrings. So thanks a lot for following this. I hope it makes sense, and see you later. Hi. Today we're going to have only one code experiment. That's because in the code exercises for today you're going to have many exercises. So we want to adjust the time so you don't feel overwhelmed. This experiment is about docstrings, which is these strings. Today you learned that you can use these strings as documentation strings, also called docstrings, for functions. But these kind of strings with these triple quotes can also be used for another purpose. They can be used outside of functions, and you can store them as you do normally in a variable. So write 3 quotes, make a break line, another one, another 3 double quotes, and in between you can write multi-line text. So with normal strings, usually you use them for short pieces of text, usually 1 line. But sometimes you might have text which spans across multiple lines. In that case, you want to use multi-line strings. So these are also referred to as multi-line strings when you use them outside of the functions. So for example, let's say we have this multi-line string. You can type in some text, several lines, whatever you like. Like that. And so there I have a multi-line string. Now what is the benefit of this? Well, if you print text now and I run this program, you see I'm going to get here the string as it is in here. So I didn't need to provide this special \n character which creates break lines, because these break lines are recognized by Python by default. So if you had a normal string, first of all, it's not recognized when you have it like that. You can get away with it by having here a backslash here, a backslash there, and here as well, So everywhere you have a break line, you need that backslash, and that would be fine. But if I run the script, this still is read as a plain string without break lines. So if you wanted break lines with a simple string, then you'd need to add, before that you need to add \n, run. Now principles of productivity is in one line, and you can do that for all lines. So you see that it becomes impractical to use a simple string when you want to have multi-line text. Therefore, the solution is multi-line strings with triple quotes. So use multi-line strings whenever you have text which expands in more than one line. Thanks a lot and see you later. Welcome to today's bonus example where you learn about decoupling. Decoupling is a concept every programmer should know no matter what programming language you are using. Let me explain decoupling to you. This code here is the code we wrote in yesterday's bonus example. It asks the user to enter feet and inches separated by a space, for example 4 feet 10 inches. If you press enter, the code will convert that. So first it will convert it to floats, so it will split this into the string 4 and the string 10, and then it converts the string 4 to the float 4, so we can do math operations with that object. The same for 10, and then we convert it into meters. So these floats, we convert them into meters and we return the meters, and then we check if the result is less than 1 meter, the kit cannot use the slide because it's too small. Otherwise, the kit can use the slide. So far, so good. So what's the problem here? The problem is that this function is doing too much. What do I mean by that? It's doing too much because it's doing more than one thing. The first thing it's doing is that it is parsing this string. So we get this as a string, so that's stored here, right? Like for 10, like this. And then this feet and inches is passed in here, and that string is being parsed, so it's being split and it's being converted into numbers. That is one thing that the function is doing. And the second thing is it's converting the floats, these numbers, into meters. So it does both the parsing and the conversion. This is not a good thing in programming because it makes the code more complicated. So the solution here is to do decoupling. And decoupling is simply the process of splitting or dividing the responsibilities of a function. Practically, that means we need to create two functions here instead of one. So let's do that here. We should have a function which does the parsing. Let's call it parse. This gets feet and inches, so that's string, right? And this one will get this code, these lines here, and return feet and inches. So in this case, we can return like a tuple, feet, inches, like that. So in this case, this happens to return two variables, right? Another case could be one variable, but basically we can return those two variables as a one single tuple. That's another topic. So this is the parsing function, and then we have the convert function. The convert function will convert feet and inches to meters. So it's getting two arguments, right? Let's say feet and inches. And then it gets that. So it expects this as a number, so it's a clean function. It's a clean conversion function. It gets number, it does a math operation, and it returns meters. So here we have decoupled these two functions. Perhaps it's more lines of code, but the code is more organized. Now let's see how we can call these functions. So one thing at a time, you first parse the feet and inches. So we call the parse function, we pass feet and inches, so this variable goes here. Don't confuse that name with that. This could be something else, so like you could do it like that. That's just a local variable, right? Feet, inches, feet, inches. I'm changing it just to make it clear to you that this is another variable, global. It's defined outside the functions, and this is just a local variable. It's an argument. Right, so feet and inches. So this will return a tuple. Let's say feet, inches, tuple. So it's a new variable. It's equal to that. And then the result will be convert. Now convert gets two arguments, feet and inches. So you could do feet, inches tuple, get the first argument, and then same feet, inches tuple, get the second argument. Right. Let's execute the code, but I'll also like to print the intermediate results. So these intermediate variables here, just to show you what's going on. So print feet and inches. Let's put a label here. FI, so feet and inches. And yeah, let's run this code. So enter feet and inches. So this asks us to enter feet and inches for 10. Press enter, and this is what we get from this line. So the function, the parse function, is returning a tuple of floats 4.0, 10.0. So it's a clear tuple of numbers. And then we pass that tuple to the convert function. Actually, we pass the first item, which is 4.0, so that goes to the feet argument, and then the second one goes to the inches argument. Now, to make this more Pythonic, the code, we don't have to write these parentheses in the return function. You can just do return feet, inches, and that will still return a tuple. Let's check that for 10. So it's the same thing. The function still returns a tuple, as you can see here. But this is more clean. Another change we can make to make the code even more Pythonic is in here. So you see this one, this will be a variable holding a tuple, right? Since this returns a tuple, this will hold a tuple, as you can see here. But since we need the items separately, because we are using them here separately, we can just do like fi, so feet, inches, so two variables, right? What this will do is, you can see here fi, this will extract these variables separately. So f will be equal to 4 and I will be equal to 10. And then in here you can do f and I. And the results will be the same. So feet, inches for 10. Let's see. Yes. So fi, so this line here, f is 4 and I is 10, and then we pass those to this function. So just to be clear, the last two changes where we changed this, making it without parentheses, and also this change here, have nothing to do with decoupling. So this was just writing cleaner code. Decoupling was about splitting a function into multiple functions, each doing a single task. This has advantages, so it makes the code easier to debug if you have a problem. It's easier to find and fix that problem. And also, if you're extending this program, perhaps you need the feet and inches as numbers in your code as you are developing, as you are extending the code. Perhaps you need to use these as numbers. So in that case, you can just call the parse function to get the variables, and then you can do something else with those numbers. But the previous code didn't allow that because it was doing everything and just returning the meters. So we didn't have access to the feet and inches as floats, right? So that's one more reason to have the functions decoupled. With that, I thank you for following and see you in the next videos. Hey, in this video we will talk about Python versions. You will understand what a Python version is and why it is important to know about Python versions. So let's begin. Let's talk about some history first. Python version 1.0.0, or simply Python 1, was released in 1994. And 6 years after that, Python 2 was released in 2000. 8 years later, Python 3 was released, and currently Python 3 is the current version. Now, these were major releases 1, 2, 3, but there are also minor releases and patch releases as well, which I'll talk about now. So when you download a Python interpreter from python.org, you download something like Python 3.11.2 or Python 3.12.7 or Python 3.10.8, etc. Now, the last number is the patch release. So this is a release of a new Python version. For example, when we switch from 3.11.1 to 3.11.2. So the Python developer team releases Python 3.11.2. And in that release, what happens is that there are bug fixes and other small changes in that particular release. Now, this release is backwards compatible, which I'll talk about in just a bit. Then we have the minor releases. Now, these are bigger features. So it's about, for example, switching from Python 3.10 to Python 3.11. So the second number indicates bigger features in the newer version that is released. And this is also backwards compatible. Now, when we have a major release, for example, when we go from Python 2 to Python 3, there are many big features that were released and the code is not backwards compatible. Now, what does backwards compatible mean? This is what I'll explain right now. So let's look at an example for that. Here, in this window here, I've started a Python 2.7 interactive shell. So I'm using the interpreter of Python 2.7, which was released many years ago. And down here, I've started a Python 3.10 interactive shell. So I'm using the Python 3.10 interpreter down here. Now, in Python 2.7, to print a string, we could use print hello, just like you see it here, without the parentheses, and you'd get the hello string. But in Python 3.10, if you do print hello, like that, you'll get an error. So that means Python 3.10, or to be more exact, Python 3 is not backwards compatible. Because what's exactly a release? A release, for example, when Python 3 was released, what happens is that two things. First is that an interpreter program is created and you can download that, but also the documentation of the language changes to fit this new interpreter. So the new interpreter expects this kind of code, print with parentheses, so like that. So the new interpreter for Python 3 expects that code, and in the documentation you'll also see this code documented. And so this new version of Python, Python 3, ignores the code that was available in Python 2. Now, practically, for programmers, what does it mean practically? Well, let's suppose that you have written a web application and the code is something like this. Let's suppose this is the code. So you have written it in Python 2. And this code is now running on a server computer, and this code produces your website, your web application. But now Python 3 is released. So you have two choices. Either you ignore Python 3 and you keep running this code using your Python 2.7 interpreter or 2.6 or whatever, so Python 2, and your app will keep running just fine, right? So you can ignore Python 3. Or the other option is that you go to your codes and you make the necessary changes. So you add parentheses here in this hello string, and here row input, you change it to input because in Python 3 row input is not used anymore, so input is used instead. And so once you make these changes, then in the server you instruct your server to run your codes using Python 3, the Python 3 interpreter. In that case, you can say that you have upgraded from Python 2 to Python 3. So after doing these two things, changing the code to fit Python 3 syntax and also changing the Python interpreter to run this code using the Python 3 interpreter. Now this could be a hassle, so many programmers could just leave the code base to run on Python 2 and they don't change the code. But after many years, Python 2 will not be supported anymore, so there might be security issues with Python 2, and in that case, as a developer, you have to go to your codebase and change the codebase to Python 3 so that you benefit from this minor releases of Python, like the minor release here and the patch, which will happen in the current major version of Python. But in the previous major versions, such as Python 1 or 2, these changes will stop after some time. So the developers of the Python team will not be working anymore on Python 2. So that's what you should know about Python versions. Now, as a learner, it doesn't really matter if you're using Python 3.10 or Python 3.12. The changes are very, very small. And so the code you wrote using Python 3.10 in mind will work even if you run it with Python 3.12 later on, because you are still in the same major version. Only if Python 4 is released later on, then you might want to think about upgrading your code to Python 4, as I explained when I did the comparison between Python 2 and 3. Yeah, with that, thanks and see you later.